Hello, everyone. So this is set 4 of our course review for Math 1324. And we're going to work on questions 31 through 40. So we're going to start with question 31, and it reads, find the future value for the annuity due with the given rate, payments of 12,000 for 10 years at 0.22% compounded monthly. So let us go ahead and find that quantity. Let me stop sharing here so I can write down the formula. So this is question 31. Make sure that you can see that clearly. And we know we have a payment of 12,000 and the time is 10 years. And we have interest rate of 0.22%, which remember we have to convert to a decimal, so we can say, okay, 0.22 divided by 100, that's going to give us 0.0022, right? We move the decimal 2 places. And so we have our rate. And the formula that we are going to use for the future value of an annuity due, let me write that down. So the future value of an annuity due, the formula will be the payment, PMT, times, and then we have 1 plus I in parentheses raised to the n minus 1 minus 1. We're going to divide that by I, close parentheses, minus PMT. And so PMT, this PMT is the payment at the beginning of each period, right? And so we have N is the total number of interest periods. So N is gonna equal, we have 10 times 12, which will be 120, right? And then the I we can compute as the R divided by our N, right? Our M, number of periods per year. So that will be where M is number of periods per year. So the R is going to be, as we said, 0.0022, and I divide that by 12. So that's going to give me my I, right? So this is my I. So I'm going to be using this ratio in the formula. Okay. Now let's plug in. So we know the payment, the time. We don't have to convert time because we have already years. So we just plug everything into the formula. So we have 12,000. And then parentheses 1 plus 0.0022 divided by 12. And then n is 120 minus 1, right? Remember, minus 1. Sorry, plus 1. This is supposed to be plus 1. I apologize. Plus 1, and then minus 1 is this minus 1. I got confused with this minus 1. Divide that by 0.0022 divided by 12. Careful here with these formulas. Make sure you write everything down. Sometimes the students try to plug everything in without writing it down, and that can be a challenge. And when you enter all this information in your calculator, the future value for the annuity will be given to you. So let's go ahead and enter this in the calculator. And we have, and you may have a different calculator, so be careful here when you do that, when you're entering everything. So 12,000, and then we're going to put a parentheses, and then we have fraction, and then another parentheses, 1 plus another fraction, 0.0022, divide that by 12, and then I'm going to close this parentheses, raise it to the 120 plus 1, so 121. And then bring down the cursor. I'm going to do minus 1. And then go to the denominator. and then it's going to be a fraction, 0.0022. Be careful there, I missed a 2. 0.0022. Careful there, divided by 12. And then close the parentheses, the main parentheses. And then remember minus 12,000. So minus 12,000. Oops. 12,000. And that should give you this number, 1,456,000. And we're going to round to the nearest. I believe the instructions, let's go back to the instructions in the review and the document here. It says, do not round until the final answer and then round to the nearest dollar. So it's going to be $1,456,089. Okay? Rounded to the nearest dollar. So $1,456,089 for the future value. Okay? So that's question number 31. All right. Let's move on to question number 32. And so question number 32, for the sake of time, since I already showed you how to enter everything in the calculator, I'm just going to write down the information. Okay, and then you need to enter that into the calculator. So that's 31. Let me see. 32, we have find the payment made by the ordinary annuity with the given present value. Okay, so we have the present value. And then we have, let's write down what we know, what they're giving us. So for 32, I'll share my screen in a moment. Let me write down what we know. So what do we have? We have the present value of 77,446. We have the time is 26 years, right? And so monthly payments for 26 years. So time is 26 years. And then the interest rate is 5.8% compounded monthly, right? So now we have to find the payment made by the ordinary annuity. So this is compounded monthly. So let me stop sharing here. So compounded monthly. So I can say, my M is 12. M is the number of compoundings per year, and N will be the total number of compoundings. So then N will be the 26, right? Because we know it's 26 years times the number of compoundings per year. So that's going to be 312, okay? Now, the I, we can say, okay, remember this R, we need to convert. So the I, we have to find I. The I would be equal to, once you convert this one, 5.8, as we did in the previous problem, this is going to be 0.05, right? 0.058. And so I is going to be 0.058, or if you want to write 0.058, and you're going to divide that by 12. That's your I. And so we have, let's see what we get here. Since we did, number 31 in detail, I'm just going to go through it this one a little bit faster. So 0.058, and then we divide that by 12. It's going to give us, remember, we don't round until the final answer. So 0.0048, and then we've got how many threes here? 1, 2, 3, 4, 5 threes. Let me show you. Okay. So that is what I'm getting there for the present value. For the time, the R is the interest rate, but remember we have to convert to a decimal. Number of compoundings per year gives us times 26 years gives us the number of and will be the total number of interest periods, right? And so I is the we have to figure out I, because that's what we're going to be using in the formula. So now the formula for the payment is going to be PMT is equal to the present value. And then we're going to multiply that. And then we're going to take I divided by 1 minus 1 plus I raised to the negative n. Okay. And so that's going to give us the present value is going to be 77,446. And then we're going to multiply I, which is, remember, we found I to be 0.0048, and then the five threes. We don't round yet. All that divided by 1 minus 1 plus the I again. Okay, raised to the negative n, which is negative 312 n. Okay, all that. So once you enter this into the calculator, let me show you, you're gonna get, that's okay, so first 77,446 times, and then fraction 0.0048, and then 33333. We're gonna divide that by 1 minus parentheses 1 plus 0.0048, and then 33333. Close. Raise that to the negative 312. And then let's close all the parentheses, the main parentheses we close. And that should give us a payment of $481. And I get 23 cents here. And so, and you know, if you get the cents a little off, and maybe some number there that we missed, but this is what we're getting. So 481 and 23 cents. Okay, just check your numbers. If I'm a little off here on the cents, and maybe I forgot to put a 3 somewhere in the calculator, perhaps. I would think that's what happened there. But okay, so you saw the process there for number 32. There's the formula for the payment. How do you get the I, and you know how to come up with the n as well. N is just the number of years times the number of compoundings per year, gives us the total number of interest periods, right? For that problem, total number of interest periods. So make sure you don't confuse the M, which is total compoundings per year, with the N, which is total interest periods in general. So in total, we have 26 years times the number of compoundings per year gives us the total number of interest periods, which is N. Okay? All right, so that's question number 32. We're moving on to 33. Let me go ahead and share the screen here. Another finance question, and it reads 33. Find the payment necessary to amortize, so pay off, a 4% loan of 1,100 compounded quarterly with 17 quarterly payments. Okay, so we're going to use really the same formula that we used. The only difference is, well, it varies a little, so I'm going to give you a different formula for this one. So the formula I'm going to give you for this one is, so, well, first of all, let's go ahead and write down the information that we have here. So for 33, we have to find payment, PMT, and we want the interest rate is 4%, right? So R is equal to 4. And it is the present value given here is $1,100. It's compounded quarterly, so my M, compounded quarterly, my M is going to be 4. And then, well, it's already telling me 17 quarterly payments. So then I don't have to compute it. It's given. So N is actually 17. Okay. My N is 17 here. And now we're going to find the payment and we're gonna round to the nearest cent. Okay, so they told us already. Remember that for the R, we have to convert to the decimal for the decimal quantity. So we have 4 divided by 100. That's going to be 0.04, right? Present value is given, and then also the total number of interest periods is given because it gives us total number of quarterly compoundings, which is 17. So we can just go ahead and plug this into the formula. So PMT is going to equal, so this is the formula for that, PV, present value times I, and we're going to divide that by 1 minus, parentheses 1 plus I to the negative N, right? Remember, N is the 70 quarterly interest payments, so N is 17. And so we have present value is 1100 times the I. Remember, I will equal the 0.04 divided by 4 because it's compounded quarterly. So we've got, that's going to give us 0.01, right? And so we have I is 0.01 divided by 1 minus 1 plus I, 0.01, raised to the negative N, negative 17, right? So if we plug all that into the calculator, it's going to give us the payment. And so if we parentheses, present value 1100, and then times 0.01, right? And then 1 minus parentheses 1 plus 0.01, close parentheses, and raise that to the negative 17. And that will give us the payment of $70. Remember, we're rounding to the nearest cent, and 68 cents. $70.68. Okay? So present value of an annuity with N payments, PMT dollars, each at the end of consecutive interest periods. The interest rate is I, and you've got all this information, and then we can figure out our payment, okay? Now, I would just write down these formulas. These formulas are the formulas that they're using in MyLab, so you're going to be familiar with these formulas from the homework. So I'm using exactly the same formulas that are being used in the homework because I don't want to give you different formulas and then you may be, because there are different versions of the formulas, but really they're all derived from the same place. So just kind of become familiar with each question and then write down, okay, this question, use this formula, and so on. So that you know, when you take the final, you know exactly which formulas to use. All right, moving on to question 34. And we have another finance question. It says, find the monthly house payment necessary to amortize a 6% loan of $221,400 over 15 years. So this is a mortgage. And we're going to find the loan, the principal and interest payment amount of a loan of $221,400, and it is over 15 years. So we have to figure out the total of interest payments, the interest rate, before we plug it into the same formula. This is the same formula as 33, but we need to find how are our quantities ready. So, okay, we know the present value. Let's begin by writing things down. So 34, we have a present value of 221,400. We have a time of 15 years to amortize this loan, pay it off. We have an interest rate of 6%. Right now, mortgage rates are a little higher than that for 30 years. And for 15 years, I would think it's lower because it's less risky. But, usually the fewer years, the better rate you get. And so now we want to find the payment. Okay, so let's go ahead and write these things down. So again, we have to figure out the rate in decimal as a decimal. So a 6% divided by 100 gives us 0.06. The I will be the 0.06 divided by the number of interest payments per year, which is 12, right? So that if you take 0.06, divide that by 12, that's going to give us the 0.005 for I, and as total interest periods. And so that is the number of years times the number of interest payments per year or compoundings per year. That's going to be 12. So 15 times 12 is 180. And so now in the formula, we're going to plug in PMT equals, we have present value times the I, divide that by 1 minus parentheses, and then we've got 1 plus I raised to the negative n. Present value is 221,400. I, as we figured out, is going to be 0.005. I'm going to divide that by 1 minus 1 plus 0.005, divide and raise that to the negative 180. Plug that into the calculator, and you get your payment for this mortgage. This does not include taxes and insurance, it's principal and interest. So we've got present value 221,400, and then 0.005, and then 1 minus parentheses 1 plus 0.005, close parentheses. I'm going to raise that to the negative 180, and that will give me a mortgage payment of 1,868 and 30 cents, rounding to the nearest cent. That looks like my home, my mortgage payment. That's very close. Yes. Oh, but you know what? No, but my mortgage payment is this amount, but with everything, taxes and insurance. So my principal and interest is only about $1,008 because I bought my house a long time ago, back in 2010. So that is a long, long time ago. And I'm very blessed to have bought in those times because the prices were really low for the area where I live. So that was a very, very good decision back then. Okay, so that's a mortgage payment for this particular loan. So let's go ahead and do now 35. Okay, finally, no more finance questions. Although, you know, I love finance questions. That's my field. And I love economics and finance and math. Math is also one of my passions. Not that, you know, we're here to discuss that, but I wish you were live here so we could have a conversation, you know. All right, anyway, now let's go move on to 35. And right now we're going to talk about solving systems of linear equations and two unknowns, x and y, represent the unknowns. And we're going to solve using the substitution method, which basically means you solve for one of the unknowns in terms of the other one. And then when you replace that into one of the equations, usually, of course, the one that you don't use in the first place. And then, you know, you solve based on using algebra, and you're going to see, I mean, it's a really fun process. So we got to just go through that. And then there's a second way of finding, actually, there's more than a second way. But right now, we're just going to use substitution. So we're going to go to 35. And now we are looking at it. So let me write down equations 1 and 2. So 35, it's use the substitution. So I'm gonna write solve by substitution. And I have two equations, 6x plus 7y equals negative 42, and 5x minus y equals 6. And so now I'm going to do something, I used to love doing this back in college, you know, just labeling the equations, say I'm gonna have equations 1 and 2, and then I'm going to use, for example, let's just say, because equation 2 looks easier, solve, so I'm gonna make myself a little note and say use equation 2 to solve for y, right? And so I'm gonna do that. So I have equation 2, 5x minus y equals 6. And so I'm gonna solve for y. And the way that you solve, excuse me, I'm moving my chair here, is you're gonna subtract. You wanna isolate y, so you subtract 5x from both sides, so minus 5x minus 5x. And then you see how we get rid of 5x here on the left side. So you bring down negative y equals, and then we have minus 5x plus 6. And we're solving for y, not negative y, so you can divide by minus 1 or multiply both sides of the equation by minus 1, either way. And then this is going to get rid of the negative sign, so we have y is equal to, and then we have negative 5x divided by negative 1 gives me positive 5x, and 6 divided by negative 1 is negative 6. So I'm going to call this one y star, or just star. Let's just call it star, okay? Now we're going to plug star into remember, we use equation 2. So because you use equation 2 now, what we're going to say is we're going to plug star into 1. So that you have to use the other equation, not the same equation. We're going to plug star into y and solve for. So if you go into 1 and you plug in, you're going to solve for not y, because you already solved for y, you're going to solve for x, right? Now you're saying, well, what do you mean you solved for y? You did. You don't have the value for y yet. That's why we have to find x, because if we find x, we plug it into star and then we're done, right? Basically. We're done with, finding the value for both, really. So now plug star into 1. So 1 is 6x plus 7y equals negative 42. So when you take star, which is y equals, so you have 6x plus 7y. So instead of writing y, I'm going to write what y is equal to. So 5x minus 6 equals negative 42, right? So you see how we got rid of the y now, and I can just say, okay, this is 6x plus, we're going to distribute. So we've got 35x. 7 times 5x is 35x. 7 times negative 6 is negative 42 equals negative 42. Now I'm going to add 42 to both sides. And that's going to get rid of the 42. The negative 42 on the left side. And so you've got 6x plus 35x equals, and then we've got 0 here, right? And then of course you can go ahead and combine, right, these two. And you've got 6x plus 35x is going to give you 41x. Now it's 35 in just a second. That's going to give you 41x, right here. 41x equals 0, divide by 41, divide by 41. You can see that x is going to give us 0, right? So once we have the value for x, we can go back to star and then plug that in here and find y. So y is equal to 5 times 0 minus 6, which you can see that that's going to give you y is equal to negative 6, right? So we've got the solution now for this system of equations, and that's going to be x is equal to 0, right? So you can write solution, x equals 0, right? And y equals negative 6. That means that these equations will cross at exactly the point 0, negative 6, okay? These two lines if you were to graph them. So, okay, that's the substitution method. It's a really straightforward way of finding the solution to a system of two linear equations. 35. Gonna look at 36 now. Let's take a look at 36. And we're going to solve this by elimination, 36. So this is a different way. Sometimes the students don't like algebra that much, and so they prefer to use this method, elimination, which works by eliminating one of the variables, one of the unknowns, and then we can use that to find the value of the other unknown, and it's actually pretty straightforward also. I don't have a preference for either one. I think both are really straightforward. So 36, we have 7x minus y equals 59. And then x plus 8y equals 41. And I'm going to, again, write equation 1 and equation 2. And let me stop sharing here. So let's go ahead and see which one. So this method is basically eliminating. You can use either equation 1 or 2. I find equation 2 to look a little bit easier than equation 1, but usually students like to just use the first equation. So let's go ahead and take a look at equation 1, and let's say we want to eliminate x. So I'm going to eliminate x. And so how do I do that? So I'm going to write equation 1, and I'm going to say 7x minus y equals 59, right? And I'm actually just gonna use equation 2 because it's a lot easier. So let me just use equation 2. So I'm gonna leave 1 as is, and I'm going to use equation 2, and I'm gonna multiply equation 2 by -7. Yeah, because that's a lot easier. So notice what's gonna happen. So I have equation 2 is x plus 8y equals 41, right? So make sure that, you take the whole equation. So this is equation 2, and I'm going to multiply the entire equation 2 by -7, which is going to give me -7x plus, well, actually it's going to be minus, right? 56y. And then -7 times 41 is going to be a -287. So this is going to be your equation 2, but revised. So I'm going to put a little apostrophe there for revision. Okay, so then what you're going to do now, you end up with -7x minus 56y equals -287. So put together equation 1, 7x minus y equals -59. And the revised equation 2, minus 7x minus 56y equals -287. And then we're going to put them together like this. And then we're going to vertically add them. Okay, so 7x minus 7x you get rid of. And then we have minus y minus 56y is minus 57y. And then a minus and a minus, minus 59 and minus 287, let's see, gives me -346, right? Oh, but you know what? Sorry about that. This one was positive. I apologize. This right here was positive. So be careful there. I almost made a mistake of keeping this one. I wrote it negative, but it was positive in number 1. So this is positive. So it's 59 minus 287. Okay, 59 minus 287. And that gives me -228, right? Minus 228. And then I can divide now by -57, both sides. That's going to get rid of the -57 there. So the y is going to equal, this is going to give me a positive, right? Because a negative divided by a negative. So 228 divided by 57 gives me 4. So y is equal 4. So I got the first value, y. Now you can plug in this 4 anywhere, either into 1 or 2. I choose 2 because it's easier. So you can plug, I can just write this down. So plug y equals 4 into either equation, let's say equation 2, and I'm going to find a value for x. So you've got x plus 8y, so 8 times 4 equals 41, right? So we've got x plus 32 equals 41. And so if you do subtract 32 from both sides, right? That's going to give us x equals 41 minus 32 will be 9. 41 minus 32. Yeah, that gives us 9. So then y is equal to 4 and x is equal to 9. So that's the solution here using elimination, right? So that's how you do this by elimination. So just to summarize everything, you have two equations. Choose to eliminate either x. You can eliminate either x or y. So I chose x, and I chose the second equation to work with the second equation because it's easier in the sense that it doesn't have any negatives. So then I multiply the second equation by -7 so that I can get rid of the 7x right here. So the 7x will cancel with the negative 7x, and that just gave me negative 57y equals negative 228, and then that gave me the value of y. Once I solve for it, I can plug this y value into either equation 1 or 2 to find the x value, okay? So that is solving a system of linear equations by elimination. That's 36. And we're going to go now to 37. We're almost there. We still have some. So 37 is a word problem, and it reads, according to projections through the year 2030, the population Y of the given state in year X is approximated by state A, negative 5x plus y equals 11,600. State B, negative 135x plus y equals 9,000, where x equal to 0 corresponds to the year 2000 and y is in thousands. Okay. In what year do the two states have the same population? So remember, y is the population. Y represents the population. And you're looking for the year, that means the x, where the two states will have the same population. So if you look at the two equations, these are linear equations. So if you were to graph them, you have two lines. And so where the two cross, that is where the two will be the same. So if you're looking for what year, which you're looking for the x value, where the two lines will cross. So it would probably be a good idea to write both of those equations in terms of y as linear equations, because then you can graph them, and then you can either graph them or solve for them algebraically. But notice that the y represents population. So you're looking for in which year they have the same population. That's an easy problem because that's where the two lines will intersect. So if you find the point of intersection, you find the answer to this question. So that is exactly what we're going to try to do here. So first, we're going to write down the two equations. We're going to write down the way they are written there. Let me write them down, and then we can solve them. So this is not a difficult problem once you understand, right, what they're asking. So we have state A, we have a negative 5x plus y equals 11,600. And then state B is negative 135x plus y equals 9,000. Remember, x represents year. X equals 0 corresponds to the year 2000, right? So x equals 0 corresponds to the year 2000. Okay, so year, and then y corresponds to population in thousands. So I'm just writing down the information that we will need. And then we're looking for when these two will have the same population. So what we can do is we can begin by solving both equations for y. So solve for y, because that represents population. And so we have, if we have a here, let me solve for y. We've got negative 5x plus y equals 11,600. So if you add 5x to both sides, that's going to get rid of the negative 5x. And so you have y equals 5x plus 11,600. So this is equation, this is the state A. Now you do the same for state B. You do the same for state B. We've got negative 135x plus y equals 9,000. Go ahead and solve for y. So add 135x to both sides. So that's gonna get rid of the negative 135x. And so you have y equals 135x plus 9,000. That's for state B. Okay, so we've got both state A and B. Solve for y. This is important because now you can set the two states equal, because you're looking for when do they have the same population. So go ahead and say A equals B. You want the same. What is A? Is y. So what is it? 5x plus 11,600 is equal to B, and B is equal to 135x plus 9,000. and go ahead and solve for the year now. And so now for the year, we're going to do minus 5x, right? That's going to get rid of, you want to keep the x positive, so that's going to get rid of 5x there. 11,600 is equal to 135x minus 5x is 130x plus 9,000. And then go ahead and do minus 9,000 on both sides. And that's going to give you 2,600 here, right? Equals 130x. And then you divide by 130, which will give you x equals, remember x is a year. So you've got 2,600 divided by 130, which gives you 20 for x. Now remember that the year x equals 0 corresponds to the year 2000. So x equals 20 will correspond to the year 2020, which that is when the two states will have the same population, right? The two states will have the same population in the year 2020. Okay, so that's question 37. I'm just speeding up a little bit here so that the video won't be too long. Now, we couldn't do that with the finance questions because those take a long time to just figure out which formula to use, right? And then plug everything into the calculator. All right, so that's 37. Now we're going to 38 and 30. Actually, that was 37. Yeah, now 38. And 38, we have, hold on a second. Where's my 38 question? Right here. Okay. We have the reduced row echelon form of the augmented matrix for a system of equation is given. Okay, once you have the reduced row echelon form, that is basically the matrix that you need is the identity matrix basically that we need on the left side of the solutions vector. And so we have the everything we need to figure out the answers to the unknowns. And so you want to look for the diagonal here of ones and then zeros under and above the diagonal of ones. If you have the diagonal of ones right here, you see how in the diagonal of ones, and then zeros below and zeros above the diagonal of ones, then we have basically the matrix already resolved. And so we have how many unknowns? We can use X, Y, Z, and W for this one. So X is the row 1, column 1. And then Y will be row 2, column 2. And then Z will be row 3, column 3. And then the W will be the row 4, column 4. Okay, so 1, 1, 2, 2, 3, 3, 4, 4. Okay, so then that is what we need. So we can write down the solution here. And basically that happens every time you have the identity matrix already on the left side of the solutions vector. And that is basically the last column of that matrix is the solutions of the problem of the system of equations here. We have how many equations there? 1, 2, 3, 4, right? So let me write that down. So if you see this type of problem, don't try to solve anything because it's already solved. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. Oops, 0, 0, 1, 0, and 0, 0, 0, 1. And then we've got 4/7. I'm just writing things down. I will share with you -3, 4, and -3. Okay. Now we have the matrix. This is the identity matrix. Why? Because we have a diagonal of ones right here. And then we have zeros under and above the diagonal. And so you can write, okay, so we're going to use X, Y, Z, and W. So those are the unknowns. And so if you were to write, you can expand this and say, okay, what if you were to write the equations here? What you have is 1 times X plus, I'm just going to do one so you can see 0 times Y plus 0 times Z plus 0 times W equals 4/7. That means that all of this goes away, right? And you've got 1 times X, that's just X equals 4/7. So similarly, you can do the second row. This is row 1. So row 2, same way, it will give us what? Y, right? Y equals -3. And then row 3 will give us Z equals 4. And then row 4 will give us W equals -3, right? So you can write the solution as, so the solution, you can write it as 4/7 for X, -3 for Y, 4 for Z, -3 for W. Okay? That's because you already have the identity matrix on the left side of the solutions column. Okay? So that is basically all you do for number 38. Moving on to 39. Let's take a look at 39. And 39, let me find that. Sometimes I have, like notes I want to share with the class. And so 39, the reduced row echelon form of the augmented matrix of a system of equations is given by, find the solutions of the system. So again, notice it's the identity matrix, not quite, right? Because you have, well, it is, and at the same time, it doesn't look like it because we're missing a 1. So what does that imply? So it implies something significant. When you look at the third row, we're missing that 1 for Z, right? So what does that mean? So we have to understand what it means in terms of the interpretation. So 39, we have 1 0 0 0 1 0 and then 0 0 0, and then the column, the solution column, the third column, the solutions column is -2 1 and 4. And then so if we were to expand this one, and we should, what does it look like? So say we have X, so 1 times X, so row 1, right? Let's expand row 1. Row 1 is 1 times X plus 0 times Y plus 0 times Z equals -2. Okay, that just tells me that, okay, all this disappears, and so X is equal to -2. All right, what does row 2 say? Row 2 tells me that we have 0 times X plus 1 times Y plus 0 times Z is equal to 1. So all this goes away, and then I've got Y equals 1. So, okay, I've got X equals -2, Y equals 1. But if I expand row 3, I get 0 times X plus 0 times Y plus 0 times Z equals 4. So this means 0 plus 0 plus 0. So I get something like 0 equals 4, which is false, right? This cannot be true. So this is a false statement. Because this is a false statement, then nothing else really works here, right? This means that there's no solution to the system because I cannot find a value for any of these that will give me 0 equals 4. Never, right? And so we cannot have the 0, right, is equal to 4. This is false. So we conclude that this system has no solution. So that's important to note. So every time you see a row that makes no sense in terms of always set it equal to the solution. Remember, the last column is a solution. So you see how that will never work, right? 0 equals 4, that's never true. So this is no solution for the system. This system has no solution. And when you look at the choices here, sometimes it says the null set, sometimes, so let's take a look here at the choices here. And you would choose, of course, C, that the system has no solution. Okay? Now, what happens if we have, now, I want you to look at the difference between number 39, where we have a contradiction with the third row. The third row gives us a contradiction for 39. We have 0 equals 4, which is false. Now, when you look at number 40, the fourth row has all zeros, and that equals 0. That is not a contradiction. That is actually a true statement, right? And so how do we handle that? That's a different situation. We can't say there's no solution there. On the contrary, there's actually many solutions. In fact, infinitely many solutions. So you have to recognize the difference between one case where you have a contradiction, then you say no solution, versus you have a statement that is always true, then in this case, you will have an infinitely number of solutions, but you need to know how to express them because they have a certain form that we need to know how to write. And that's going to be our last question. So we need to understand how to write the solutions when we have an infinite number of solutions and when we have the case of an infinite number of solutions. So let's try to understand how to go about that. So when we write down the matrix, we have 1, 0, 0, 2. And then we've got that is equal to 15. And then 0, 1, 0, 6, that is equal to -2. And then we've got 0, 0, 1, 0, that is equal to -3. And then 0, 0, 0, 0 gives us 0. So we need to find the way to, so we know, we know because we have this situation here. This tells us that there's an infinitely number of solutions. When we look at row 4, right? So just expand row 4. Just look at row 4. And so we've got 0x plus 0 times y plus 0 times z plus 0 times w. That's going to give me 0. So everything gives me 0 equals 0, which is always true, right? We're going to say, well, this is always true. What does this mean? Infinite number of solutions. So many, many, many solutions. Now we need to find the form. We need to find which form do these solutions have. No. So we know it's an infinite number of solutions. We need to find the form or how to write the solution set, the form of the solution set. So what is the solution set form, right? To do that, we have to write all, we're going to expand or write each equation and say, okay, 0x plus, 1 times x, right? For row 1, so we start with row 1, and we say, okay, this is going to be 1 times x plus 0 times y plus 0 times z plus 2 times w equals 15, right? That's row 1. Row 2 is going to be 0 times x plus 1 times y plus 0 times z plus 6 times w equals -2. And then row 3 is going to be 0 times x plus 0 times y plus 0 times z plus 0 times w equals 0. And then row 4 we already had looked at is all zeros, right? 0 times x plus 0 times y plus 0 times z plus 0 times w equals 0. Okay, now we don't really worry about this one because it doesn't give us anything. Now row 1 does imply something because you notice how everything is 0, right? Now notice here, this is 0, that is 0, but then we have, so let me simplify it. We have x, right, plus 2w equals 15. Now solve for x here. If you solve for x, you're going to get x equals -2w plus 15. So solve for x from row 1. And I didn't do the steps here because of lack of space, but just solve for x by subtracting 2w from both sides. Now row 2, you do the same for y. So you've got, notice how the 0x is just 0, 0z is 0. So you've got the 1 times y is y plus 6w equals -2. Go ahead and solve for y, and you get y equals -6w minus 2, right? When you do minus 6w from both sides, okay? And then the last row will give you, not the last row, row 3. Look at row 3, and you get 0 here and 0 for row 3. Oh, this one for row 3, sorry, this should be a 1. I apologize, this one I made a mistake here. This is -3 here, and this is a 1, right? Apologize. So I fixed that. It's 1 times z, and then that's a -3. So then 0x, 0y, 0w, and so you just have 1 times z equals -3, so z equals -3, right? So that's row 3. And so now, we've got x, y, and z, and what does that mean? It means that w is left, notice that w is just left there, like, so what about w? So z is equal to -3, right? Now, Y depends on W, and X depends on W, notice. So that means that W can be any real number. So W doesn't depend on anything. W can be any real number, right? So how do you write then the solution set? The solution set, then you write it, because now make a note here that W can be any real number. I'm going to make a note here. Note, W can be any real number. So is any real number. Okay, so W is any real number. So how would you write the solution set? Well, it's going to be X, and so write it in terms of W, because W can be any real number. So you write X is equal to, so what is your X? So you have to start with X. It's going to be negative 2W plus 15. That's your X. And then your Y is negative 6W minus 2, right? And then Z, now you know Z does have a value, negative 3, so you put negative 3. And then W is any real number, so you just put a W there. Okay? So notice that the solution has to be in terms of only one of those unknowns, and that's negative 2W plus 15 for the X. This is your X. And then Y is negative 6W minus 2. Z is minus 3. And then, of course, W is any real number. So this is what you will write as a solution set. Okay? Okay, so that concludes set number 4, questions 31 through 40. So I hope you found this useful. And we will do the last set as well. The last one is going to be questions 41 through 50. This was a long review. It's been a lot of hard work. So hopefully this helps you to prepare well for the final exam. Thank you for watching, and I will see you on the next one. Take care.